All right, let's work some more on these sweat glands because we have them all over us, and they're very widespread in our skin. Please notice that they do originate much deeper in our dermis or in our hypodermis. And there are two different kinds that are listed here, the eccrine and the apocrine. We're not going to, and then we have the mammary glands, which we're going to kind of just gloss over. But I do want you to know that especially the eccrine, that's how I'm saying it, I hope I'm pronouncing that correctly, guys. These are the ones that we think of when we're just talking about sweating, just dirty sweating. When we're working out or when we're hot, this is what you're thinking of when you're thinking of sweating, all right? And that, notice in your textbook on page 118, it says the most numerous sweat glands, the eccrine sweat glands, or the eccrine glands, they respond throughout life to body temperature, and it's elevated by environmental heat or physical exercise, and these are common, and they're on our forehead, on our neck, and they're on our back, and they produce profuse sweat on hot days or during intense physical activity. These fluid sweat that eccrine glands secrete is carried away in a duct that opens on the surface as a pore, and you can see in this photo here on this slide that it shows the pore there. Sweat, notice it says on page 118 in the text, is mostly water, but it does contain small amounts of salt and wastes like urea and uric acid, so sweating is also an excretory function. This is our body's way of getting rid of some small amounts of dirt and toxins, so it is an excretory system. And on the next slide here, we see that a clinical application of this is when our bodies, especially in those teen years, your years, and sometimes right after, especially women, it is mostly common to women, have babies, and all of our hormones are getting all back into whack after that baby takes it out of whack, if you will. It's often common for 20-something women and now 30-something women to have acne. And acne is a disorder of this sebaceous gland. Remember what sebaceous means. Sebaceous means grease. So this gland is responsible for oils that keep our bodies and our skin cells and even our hair healthy looking and shiny and supple. And if it's overactive in people that have acne, then it's producing too much. And then if it gets too much, then it can clog those pores that are on our skin cells, on our skin surface, and that clogged pore is what causes us to have breakouts of pimples and blackheads. And those pimples are actually filled with pus, which is infection. That's what pus is. So pustules is so if you pop that, you are actually spreading that infection to the rest of your skin, and if you don't get it off pretty quickly, then that's what you're spreading, is infection. So that is the clinical definition, at least the Steed version of a clinical definition of what acne is, and it is a battle that people fight sometimes for a long, long time. All right, next we have this is one of the reasons that our skin is important and our glands are important, because it does regulate our body temperature. It's vitally important because even slight shifts can disrupt our metabolic reactions, and our skin plays a key role in this homeostatic. Remember what homeo means. Homeostatic mechanism that regulates this body temperature. The next slide here talks about our heat production and heat loss. Heat is a transferring of energy. That's the physics definition. I know that definition quite well. And so when we go through our cellular metabolism, those cycles that I didn't feel qualified to teach you, but you know, when we eat food or whatever, our body has to change that energy or that food into energy through metabolism. That's about all I know about metabolism, but I know that that's a heat releaser. And so it is a burning process, and even the way they figure out how many calories is in food. I can tell you the chemistry behind that. We do a lab on that, in fact, in chemistry. They actually literally burn the food to see how many calories is in it. So it is a heat process. So the most active body cells are the heat producers, and these include our skeletal system, our cardiac muscles, and the cells that are in certain glands like our liver. And so the primary way that we lose heat is by radiation. And when we think of radiation, we automatically think, ooh, cancer treatment. No, the physics definition of radiation is energy loss just without having to touch anything. So if I touch you, that's contact. So if I, if you have a spoon that's in a cold drink, let's just say, and you touch it, you think, ooh, that's so cold. That's because our heat is being transferred to that spoon, and we feel that heat leaving our body. That's heat transfer by contact. And then you know for a fact that if you get into the water and you are swimming, let's say in a pond or in the ocean, and you run into a really warm area, that's not a young child having gone pee in the pool, but it's current carrying warmer water. That's convection. That's convection. And then radiation is how heat gets to us from the sun. It's through empty space completely. That is a way that heat gets transferred. So conduction, convection, radiation, and then it also mentions here evaporation, which is another form of convection. So to me, that shouldn't be listed separately. But that's our primary source of heat loss. Is just it radiates off of our body. It leaves us out of our cells and through to empty to space around us, okay, without having to touch anything. All right, so then this is how our skin cells regulate our body temperature. And this picture is easier to see, I think. There's kind of a picture of this. Well, I thought there was in your textbook, but I don't see it. It just sort of explains it. On page 120, it says that the regulation of the body temperature, how very important it is. It says that normally the temperature of the deeper body parts has to stay, that's our core temperature, has to stay at like 98.6. And maintenance of this temperature requires that the amount of heat that the body loses be balanced out by the amount that it produces. So you know that people that go into hypothermia, that stay in the cold water too long or stay out in the cold too long, this is important, that they stay warm. Frostbite and things like that and it says that our skin plays a key role in this function. And so it talks about how this happens. In this system right here, I can't even see a lot of this, it shows you how that this happens. So it tells us if our body temperature gets too high, then our body automatically starts sweating. If our body temperature gets too cold, then we start shivering to help to maintain that that movement of the cells in our body is generating energy to help to warm us up. Okay? And so on this next slide, it gives us some problems in our temperature regulation. We know what hypothermia is. That's an abnormally high body temperature, and hypothermia is low. Hyper is too high. That's like heat stroke or heat exhaustion, and then hypothermia is when we get too cold. People that have been in water that's too cold for too long, or even outside in the snow too long, even small children, if they're not correctly bundled, can get hypothermia. All right. And then 6.5, healing of wounds and burns. This is in your textbook on page 120 and 121. We're almost through here now. And it talks about that what a wound is, and it's how it can be, the healing process starts. Inflammation is just a normal response to any kind of injury or stress, and that's your body attacking that wound and letting it know that the cells and the white blood cells and those kind of things, it's the blood vessels dilating that are sending more blood to that affected area to rescue it, basically. So blood vessels in that affected area and tissues, they dilate. Remember, dilate means get bigger, and they become more permeable. Permeable means letting things come through, and that's necessary so that those things that need to go battle that war that's going on with that wound can be allowed to get through. Okay, and so they're going to allow those fluids to get into that damaged tissue area and go to work there. So that inflamed skin can become swollen and red, and it become warm and quite painful, and that's the war going on to win the battle over bacteria and infection in that wound. And the next slide shows about cuts, and it just shows that it says here, shallow cuts in these epidermal cells along its margin, and what they cause it to do to divide more rapidly, and then a deep cut results in the blood vessels breaking. Now, if those blood vessels are going to break, then of course that wound is going to bleed, and then your clotting mechanism takes over, and that clot forms and stops the bleeding, and then it scabs over, and then your body tells itself, okay, now we have to form some new tissue, and so then that goes to work, and the new tissue gets formed. And that's exactly what happens here, and it shows this picture of exactly what happens. Here's your wound site, here's the scab, and here's things that all the body parts telling me, and once that scab is no longer necessary, the new skin cells, that's what these last two slides are, those last two pictures on the bottom, once the skin's adequately healed, then the new skin cells push the scab off when it's time for it to go. So when we pick it off, that's not helping your body. Then it just has to do more work to grow a new one. And then burns is another kind of wound that we deal with. First degree is superficial. Superficial means super is on the top layer, so it's only come down to part way through the thickness. Second degree comes deeper down into our dermis, and then third degree burns has come all the way down into, and then that's when you have deep scarring, and you have to do transplants sometimes, skin grafts and those kinds of things. Okay, various skin substitutes have to take place. All right, and then you have on this one it's talking about your rule of nines for adults, where it says that if so much of your body, this rule of nines, where it's talking about it, that depending on how much of your body parts and your age, it says slightly burned skin like a minor sunburn, a burn that just is has just warm and reddened. This is a first degree burn. And then a burn that destroys the epidermis, the dermis, and the accessory organs, full thickness, is a third degree burn. The injured skin becomes dry and leathery, and the burn may vary from red to black and then even to white. I've seen that actually, the white burn. A full thickness burn is usually caused by an immersion in some sort of hot liquid or exposure to hot objects, flames, or corrosive chemicals. Typically, most of the epithelial cells are destroyed, and the healing process can only occur if the injured area is extensive. It may require a transplant. We've already talked about that. I was looking for this rule of nines, and I don't see it anywhere. So I can't help you on that. I don't know what this rule of nine means. I was trying to read it on there. so I don't know what that means. I don't know to what that's referring. All right. And then on page 122, I am going to expect you to know, I believe this is all lifespan changes. Let me see. It talks about what you can expect over your lifespan. No, I don't want to go there. I want to go here. Our skin, as we get older, I'm experiencing this right now. We start getting age spots. I noticed when I was doing one of y'all's videos and drawing on this that I really have got some more age spots on the back of my hand. Our skin gets thinner, and you probably have a grandparent that, they just bruise so easy. You can just almost just touch them and see the bruise. And they also can then scratch themselves with their fingernail, and they'll start to bleed. Just the least little thing will make them bleed. So they're because their skin gets so much thinner. Of course, they get way wrinkly, and they get really, really ashy. That's because of the lot of loss of fat. So that their sebaceous glands, they just don't secrete anymore, and they sag. And I don't want any of you to say anything about me at all. Okay, and so all of these kind of things, their melanin production slows, so they get more pale, and then their hair thins, which we all know that too. Some of you may have a grandpa, and they're starting to lose their hair on their legs and on their arms. So it's just part of that aging process. And we have creams and things like that now that we can slow that aging process. But I'm going to tell you what, guys, you better start now when you're your age, and not wait until your mind to say, oh, there's an age spot, I better start applying that cream. You better start applying those beauty creams. And girls, you better take that makeup off at night right now, because I believe in the industry they say for every single night that you leave your makeup on, that is clogging those pores, girls. It's clogging those pores. And for every night that you leave it on, it ages your skin 7 days. And for you boys and girls, after practice and things like that, when you don't wash with a good soap, you're clogging those pores, those glands, and allowing those dirt and things to stay and clog those pores, and helping prevent those excretions, and so that urea and other things to stay in there, and that promotes acne and blackheads and things like that. So, and all those kinds of things. Those are the things that happen as we get older. And then these are the things that we've talked about, and the things that you're going to be tested over in this chapter. Constitutes an organ, the large organ of the integumentary system, which is our skin. That's what you need to know. And also the functions of the skin, which by now I hope you know some of the major functions of the skin. It regulates the temperature. Anyway, I'm going to let you work on that, because you need to know that. I'm going to ask you some questions on that one in your homework. The structure and layers of the skin, and the factors that determine skin color, and then the accessory structures associated with the skin, and each accessory structure of the skin. Those are the things you're going to be expected to know. Okay, how skin helps to regulate body temperature, and how all the events that take part in healing of the wounds, and the different types of burns, first degree, second degree, third degree, and then summarize the lifespan changes in the integumentary systems. These are what's going to be assessed. All right? Hope you have a good week.